Okay, I'm Jon Hodgson. I am the chief scientist for APM for Riverbed. I've been the subject matter expert for this for about 15 years now. I came through the ranks as I used to be an assistant administrator and came through ranks as an SE and worked with R&D and PM and basically I try to figure out all the new things that we need to do to solve the most complex problems in the world right now, with regard to performance. So I want to introduce you to the concepts that drive us with our digital experience management in this section, and then in my second session, we'll talk about some practical examples of devil in the details. Perspective is a big part of this for me because when we think of performance, there's so many different roles. We work with folks who are networking focused or they're application focused. We have developers, business owners. And the problem is that when they take different perspectives of the scenario, they may get different impressions. So here we see someone stranded on a desert island, super excited that there's a boat in the distance. And if we flip that, right, this person's super excited he finally found land. So the same scenario is different depending on which side of the fence you're on. And this is one of the challenges when we're dealing with digital experience management is that we have folks in one realm who think very physically about where does data live, where do people who are accessing it live, how does that connect from a physical perspective, routers and so on. And then when we think about on a application perspective, here we have people who are much more logical in terms of what are the services they're consuming, how are they interconnected with regard to flow and web services and so on, containers and whatnot. So these are very different when we're trying to get these folks to collaborate. How do we connect these worlds for them? And then, of course, the most important perspective, the third perspective is, why is it when we're in a time crunch things don't work? So I'm sorry, I developed this on a different laptop. It was supposed to be a video playing right here. All right, forget it. I'll just describe what it was supposed to be. So the third and most important perspective is end user experience, right? So for those of you who haven't figured this out, that wasn't an error. Just wanted to tick you off for a little bit and make you wait. But this is what happens in our world is that end users get frustrated. This is what ultimately is driving all of us in that who cares about application performance, network performance, if the end users aren't happy? If there are no end users to consume your service, none of that other stuff matters. And this is ultimately what we're driving for. We want to connect all of these dots for you. So with that in mind, here's an end user. And if we want to manage this person's experience, understand what they're doing, we start with the device. And then, of course, we look at what services they're consuming. So they're coming through cloud to some application. Now, this is traditionally thought of as the concept of EUE. Now Gartner calls it DEM, Digital Experience Management. But bottom line is, we know that someone is having slowness, and OK, great. But now what do I do about it? So the real trick here is to be able to solve problems. And to solve that, we've got to drill down deeper into the infrastructure that this application is made up of. And this application isn't just servers or containers or code. There's network components. And we have to bring together all of these different perspectives that people have in order to provide a comprehensive view of this environment. And to do that now, I've got to have also interleaved performance data that follows this transaction. So this is one of our big differentiators is, we don't deal on aggregates. We don't deal on averages. We treat each individual user and their individual clicks as microdata that we capture and store and analyze. So all of us in the room here, if I point any one of you out and say, OK, your response time to a banking site is slow, but their NOC says on average everything is fast, you don't care. Right? It's not about that green light in somebody's room. It's that you want to be treated like an individual, not the faceless masses. We want to make sure your experience is good. So we're capturing from the client side the end user experience of what it took before the request left the browser, all of the delay in between, characterized by network, client, and so on, resource loading, AJAX calls. And this happens on mobile devices, desktops, web pages. We can wrap our apps and so on. And then this will only tell you that there's a problem. So now we've got to dive deeper. And our NPM side of this, which is using network-based information, packets and flows and so on, they follow that transaction further into the stack and can now answer why networking-related issues are here. So I want to be clear that while this can be used by networking people to do network management, network analysis, in this context, it's about understanding the network effects of application performance problems, of end user problems. And that's really what we're accomplishing here, is connecting those dots and stitching this with that front end. And then lastly, when we talk about traditional...
Can I just quickly say something?
Yes.
You stopped at the application, or at least at SQL.
Yes.
But obviously, I know you're a network company, but there's more behind that.
Right, but we're not a SQL profiler.
No, but,
right?
But there could be plenty more behind that. That also causes a problem. And you've got one view of it, but you don't have a view of the full end-to-end picture that could affect the performance as well.
Right, absolutely. I mean, we will put instrumentation on a SQL server to monitor OS resources and the connectivity of LUNs and things like that. But just conceptually, we're just picking that as a stop point. But obviously, we want to monitor as many things as is practical and possible in this whole flow, so that we can A, detect problems, and B, narrow down and provide actionable details to fix it. But yeah, point taken. You can go even deeper. So on the APM side, right, we're monitoring, again, every single transaction. If there's 10,000 people per second clicking on some URL, we've got 10,000 unique records of that across all those tiers, stitching them together, following the end-to-end flow. That means 10,000 call stacks, 10,000 unique application maps. If some go through SOA server 1 versus 2, we understand all of that. So, and then lastly, to his point about monitoring resources, when things are slow and they're delayed, that's going to ultimately be because of some resource contention. So we're monitoring all of the infrastructural metrics about the containers, the OS, VMware overcommitment, and so on, down to second-level granularity, so that when there are these little micro spikes in response time, we can track that down very precisely to the resources that cause that. So you put all this together, that is what Steel Central is about. Steel Central is our digital experience arm of Riverbed, which is basically trying to capture from a big data perspective everything these end users do, or devices in the IoT space that are accessing, but all the consumers of data when they're trying to get to that data in those services, making sure that if things are not performing up to the levels we expect, that we can quickly identify something actionable to solve it. And I'm going to talk about a number of case studies where that takes place.
How does this relate to things like distributed tracing?
Well, I mean, so that would be, well, I mean, it depends. That could mean a number of things. But in the APM space, talking about, like, so we're recording the call stacks of the Java and .NET. We're providing unique identifiers across the tiers, connecting all those dots. That's your distributed tracing. But we're following it all the way up to the client side and also with the packets as well. Okay. So it's very comprehensive. And again, it's big data. It's not a sampled approach.
I guess on that point, it comes down to how are you getting the data, how are you integrating with all of these services, which I guess we'll find out as you go through. But distributed tracing to me also talks around service mesh and some of these newer technologies.
Right. So I mean, there's in the limited space that we have, there's so many different caveats to this. But the ultimate goal is for us to be able to integrate with these application servers, again, get data from the infrastructure as well as from inside the code. And we could talk elaborately with more time, but yes. So the goal here, as I mentioned, is to solve problems. And one of the things, I think, when people come to the table and they think of Riverbed, they'll often initially think of, well, that's the WAN optimization company, or they do networking stuff. And there isn't this stark divide between the digital experience and the rest of it, because the other pieces that we have are there to mitigate problems on the fly when possible, because the ultimate goal is improving performance. So if we take the scenario of an application call that's application living in a data center and it's accessing some report library or something like that, if we move most of this to the cloud, but we leave some piece behind, without changing anything about the request, anything about the payload, all of a sudden we get more delay because of latency, because of chattiness between this link. And so when you're thinking about a company that's moving everything lock, stock, and barrel to the cloud, they're going to have a lot of cases where these transactions all of a sudden start degrading. Now, are you going to, on a transaction-by-transaction basis, go ahead and optimize the code and try to make that less chatty? You could, but it's not going to be necessarily practical on how to do that. So with our other solutions, like, for example, Steelhead, we can put WAN optimization devices on premises as well as in the cloud, and then basically by optimizing the inefficiencies of that file transfer protocol of TCP/IP on its own, basically make these effects go away. And that's the story as we talk about Steel Fusion and how that applies to storage and Steel Connect and SD-WAN of making sure we can find the right pathways and the most optimized pathways between the consumers of data and where that data ultimately lives. That's what this is what the whole Riverbed portfolio brings to the table. And again, other folks will talk in more detail about how we do that rectification. But I don't want you to think about this as two separate things. So back to the perspective concept. Why do I keep harping on the need to look at networking and application perspective at the same time? So imagine this room, and on this wall we have a circle. Nobody's going to debate that. And on this wall we have a rectangle. Nobody's going to debate that. But if we take a step back and look together, these are projections of some common element. And while those initial things are true in what our observations were, the truth is the cylinder in the center. And this is a big problem in the 15 years I've been doing this, is that when people take a myopic impression and perspective on solving a problem, they quite often will see a symptom in one place, but the root cause will be somewhere else. And if they're not looking at what the reality is of connecting all these dots, they're going to go down the wrong pathway. And in the next session, I have lots of examples of where that happens. And that's basically what Steel Central is about. Instead of saying there's an NPM point tool or some APM tool, some of the other vendors that are strictly about code or servers, they only provide one part of this. And if that's all your problems ever are, that's fine. But in our experience, problems are myriad. They go across the entire gamut of the infrastructure. So now switch this practically. Portal is the way that we connect those dots for the end users. We have all these different telemetry sources because of the need, as we've discussed, from end user to the code, again, down to the method level, extracting parameters for business level analysis for every single transaction. It's really big data, billions of transactions per day type of stuff. The resource information, networks, and so on. And the challenge when you have this varied set of data is that it's not palatable to everyone. What is an application developer going to do with a whole bunch of network packets or vice versa? We have to normalize. And that's what Portal is about, is unifying this data, turning it all into sort of time series, correlated information that says, we don't care it used to be a packet. It's performance data now. We don't care it used to be a call stack. It's performance data now. And then with 12 folks or 15 folks in the room, you probably have 30 different opinions as to what your perfect dashboard should look like. So the idea here is that Portal says, look, take your data, interleave it. This is not tabs, a network tab, an application tab. It's one big pool of data. And now visualize it however you want and create the views that are particular to your role and what you're trying to accomplish. So, and the beauty of this is that we don't have the challenge with a lot of monitoring tools. A lot of monitoring tools are used defensively. It's to prove my innocence. And everyone proves that they're innocent, and the problem still exists for the end users. And we want to be more collaborative so that we can look and say, it's not about doing this. It's about figuring out exactly what the problem is so we can solve problems. And that's really the goal. And when your tool is my tool, then we're not going to have the issue of I don't trust your tool, because then I'm implicitly not trusting mine. And it's also connecting the dots from the business side. When you get an alert at, for example, some high-level application dashboard, there's no chance we're not going to be able to track that down to an actionable detail, because that's where this rolled up from. Right? So both the business level metrics as well as your business level perspective as well as the low level infrastructure information is all coming from the same place. So your dashboards can be as simple as this, or they can be as varied as you want them to be. Again, roll your own, have it your way. We can have very networky views, blended views, application views, and so on.
Excuse me.
Yes.
I have a question. In the previous slide, you showed it with the IaaS infrastructure. Does it work also with the PaaS container services?
With the which, I'm sorry?
With the PaaS container
Yes,
services?
PaaS, IaaS, SaaS works the gamut,
Okay.
absolutely. Yeah, we have solutions for all this. Even when it comes to like packet capture, we can packet capture in the cloud. We can do it through devices.
What about a situation where, you gave the rosy picture where you have Riverbed tied to every component, but that's not always the case. So how do you integrate with other solutions to pull information from them? So if you're using a different APM solution,
Right.
can you tie into that?
We
Get that holistic view?
The challenge is that there's no other APM vendor who captures all transactions all the time and does the big data analysis that we do, right? They may say that they...
Okay. I don't know if that's necessarily true, but...
That's my perspective. So,
Okay.
yeah, there are ones who capture a lot of stuff but don't let you analyze billions of transactions at once. There's ones that capture all of the end user experience transactions, but they sample the downstream call stacks 1 out of every 1,000 or something like that. So it would be hard to achieve what we're achieving, and you'll see some of the end results of that in the next block.
Okay.
But there are cases where we do pull in third-party data. It just would not necessarily be from an APM vendor. Okay.
Yeah, so I guess
Yes.
I think I might have a similar question, which is you showed lots of instrumentation points.
Mm-hmm.
You collect all of this data so that you've got end-to-end. I mean, that's one thing about instrumenting within the application is that I have an application-centric view of what I'm actually doing by adding in, like, distributed tracing. But if you've got all of these different ways of collecting that data, does that mean that I need Riverbed injection points, like agents that go and deploy on servers? Do I have to... Is there a library that I get my developers to code to and send telemetry data back into your central system
It all depends on the nature of the data. From the application perspective, we have an agent that auto-discovers the applications, auto-hooks in, auto-discovers the code. Your developers don't do anything. But you need those deployed in order to answer the question, why is there slowness within a given tier, right? Yeah. And if that tier is making an outbound call to another instrumented code tier, and the delay is determined to be in the network, there is no application, agent in the world that's going to be able to tell you that it's because of retransmissions or packet loss or something like that. So then the idea, if you need to answer that question, if that's the root cause of problems, that's why you need perspective from the network, from the wire. We have appliances that will capture, tens of gigabits per second of packets and layer 7 decoded.
Yeah, I think I'm trying to look for what is the portfolio coverage. So for all of the different bits and pieces, where do you have coverage, and are there any gaps in there which you would want to then integrate with third-party tools that would be able to put stuff, so I want Riverbed, and I've got that for 90% of the stuff, but for these 3 or 4 extra bits I need. Yeah,
I mean, again, that's a double use. We could talk about specific implementation. It's, like, do we instrument, Ruby down to the code level? No, right? So if you needed that level of instrumentation, we could do the underlying operating system in very high granularity, but we're not going to be able to do code instrumentation for that, right?
But the problem is, once you go further toward cloud, the less details you're going to have access to. Right?
If we're talking about SaaS.
No.
Right.
No, even platform as a service or infrastructure as a service, you're not going to necessarily have access to the same level of detail as if that was a traditional compute storage network stack within your data center.
Yeah, so if I start to build a solution on S3, Lambda, and RDMS, I can never remember the name of the database. RDS. How does Riverbed help with instrumentation if I have those components in the cloud? In traditional components, obviously in the data center, where's the insight into if I'm having performance issues?
Right. So, I mean, Lambda specifically, we don't have any internal instrumentation in that right now. Right. I know that they've got some ideas on what to do with that. But when it does come to things like PaaS, I mean, PaaS has a lot of definitions. Azure PaaS is much closer to IaaS than anything else. Traditional PaaS is more like SaaS. We do the best we can with what you give us. I mean, that's really the goal here, is that if you've chosen to use a SaaS vendor and that SaaS vendor says, we're not going to let you see anything inside, then the best we're going to be able to do is tell you that there are issues. But with our big data approach, we use SaaS apps as well. I get to see, and you'll see in the next block, these charts that reveal patterns that those vendors didn't even know about. And we will be able to say that there is a problem. We're not necessarily going to be able to give you actionable details of how to fix it.
So as a use case, if I have a application that's running within my data center today, and I'm starting to shift that more toward leveraging cloud-based resources, does the value of this type of solution start to get diminished?
No, it actually becomes more necessary, as we'll talk about shortly.
How so?
Because of the complexity that introduces. So I'm definitely going to get to that.
Just a quick question on the piece we were talking about with AWS specifically as a solution. Are you able to pull in VPC flow logs as part of your solution?
I don't deal with that side of the house, so I don't know. Anyone?
Because if you're not getting access to, so Lambda can plug into a VPC, RDS is using a VPC, you're not going to be able to put an agent or deploy anything into those.
Right.
But they do flow logging, so that would be a logical place to plug in and get as much detail as you could possibly get out of AWS.
Yeah, and we could table that question. that's not my side of the house, but yeah, exactly. But the idea there is, where can we get the data we need? We're constantly trying to evolve to pull it, okay? All right, great questions. I don't want to go over my time, which I'm dangerously close to doing. So tying it all together, it's not always obvious when we see something like this. This is some generic dashboard that, we've seen this everywhere, but have you? I like Futurama, and there was this line of Futurama that says, when you've done something right, people aren't sure you've done anything at all. And the beauty of this, what's seemingly generic dashboard, is that we have data coming from on-premises and the cloud, from the end user devices, interleaved with information from packets and flows, from code instrumentation, from the OS, the container, determining if there's overcommitment issues which are causing response time, and of course business level views. So this isn't, as I said, a tabbed interface. This is blended data to the point where when people are using Riverbed, they don't even know about APM packets, flows. They just know that they've got their performance data. And this is really, really critical. And lastly, the workflow is important, because having data is one thing, but being able to leverage it in the way that makes sense to you is also critically important. So here we have an example of a DevOps person who sees application issues. She drills down to a more application-centric dashboard, and then says, I got to go deeper. They can always go into the low-level microdata and see the individual transactions, analyze them in bulk. We've got big data searches and so on, and do the exact same thing for a network flow, all the way going down to packets, flows, and so on. So this is the choose-your-own-adventure model, but some people maybe want to be a little bit more corralled or maybe need to be. So here we could say in that little dashboard I showed you in the phone, we could drill down to tiers and then some KPIs here, but there's no way to go out of this. So from a video game perspective, this is your open world, choose-your-own-adventure, and this is, we feel like we're in a 3D world, but it's really a shooter and we're on a rail, and we can't really diverge too much. And we see that these are the kind of models that people want to use to consume this. So in closing, this data could be as simplistic as this, as summarized, or it could be as extensive as that. This is Maersk International Shipping. This is their NOC. They have all of our solutions, NPM-based packets, APM, end user experience. Their NOC dashboards are all Riverbed-based, and level 1, level 2, level 3 support. We're also using it for deep dive drill down. And so this doesn't have to be complicated. We're making this simple for you. And in the next block, we'll talk about sort of some of the benefits of that. So if you wouldn't mind, if this is interesting and you want to see more, follow me. I've got my link to my YouTube where I've got more talks that are kind of, this was inspired by a little bit more elaborate in some of this. Okay, so thank you. Yeah?
Quick question. The portal you're talking about there, is that a SaaS solution or is that something I deploy on premises?
It's something you deploy on premises or in the cloud, on your own server right now. But we will have an appliance variant to that in the future. A lot of our things are cloud-based now. We have a SaaS for our APM, for example.
Okay, and so if I'm deploying that on-prem, there's presumably quite a lot of storage and compute and stuff I need to run that. Because if you're running this big data platform, that typically, I mean, you can look at some other vendors, and they take up half a rack or racks to do that kind of stuff. Is that?
Yeah, Portal is a window into the data that exists in the actual collection tools. So, and that data has already been sort of scrubbed and turned into macro data by the time it gets up to Portal. So the raw call stacks, the raw packets live in their respective capture devices. And I mean, on the APM side, we could do, tens of billions of transactions in a modest, handful of terabytes. And then on the packet capture side, that's where it could get really big depending on the size of your pipe. But we have, that could be tens or hundreds of terabytes, as part of that appliance.
Is your recommendation, especially if you want some analysis over a certain amount of time, to run it in a SaaS solution, run it on your?
I think the answer is it all depends on where your pieces are and what security models matter to you. And we have customers who run entirely on SaaS. We have ones who want to run on-premises, excuse me. And it just, again, it all depends on what they're trying to accomplish. But the solution and the functionality is on parity between both. All right. So thank you with that, and I guess we're going right into number 2. Is that right? I will reintroduce myself for people who are just joining. So I'm Jon Hodgson, Chief Scientist for APM. Been doing APM for about 15 years for Riverbed. And this section is now a lot of practical examples of why the quality of the data you have is really important. So just because you have APM data or just because you have metric data doesn't mean you have something that's going to be able to accurately detect or adequately find an actionable root cause. So this leads to the question of when you go to the cloud, does the benefit of this degrade? And I would say a resounding no. The cloud has introduced complexity beyond belief. We started with multi-app VMs. We then moved to single app containers, and then we said, okay, let's do single microservice containers. And now with Lambda, it's going to get even more complicated, right? And serverless. What used to be one thing that we had to track from dependency mapping and so on, in this example, is now 24 things. What used to be one node in a map is in and of itself a map. And you get these weird, these crazy rat's nest of dependencies that are incredibly hard to track. And if I extrapolate this out now with the whole point of going to containers, go from tens of things to tens of thousands, this becomes very, very complex to manage. And when we add the additional complexity of elasticity in that we could scale up and then we could scale back down, we've left a trail of entities that we have to keep track of if we want to basically solve performance issues. And even though we might reuse some of these periodically, there are some that will come up and never come down again. So this further complicates the issue. And even if you're not scaling, transients, when you're moving your containers around and VMs around to the position of the sun or for rolling upgrades, they're going to leave a trail behind as well. So, so this creates an even more complex world that we have to live in when we have to track all of these ephemeral things that lived and don't live again. And because of this, the traditional concept of dependency mapping that we see in APM, and that all the APM vendors love to tout their pretty maps, this is what happens in the real world. Maps like this. This is from us. Very impressive that we were able to stitch a customer's application. You're probably, a number of you are probably customers of them, don't even know it, but I can't say who it is. Through all of these different tiers and within boxes and so on. What the hell do you do with this? This is useless. And this is what you're going to see in the largest environments. And every vendor suffers from this. You can aggregate by role and so on. Physical mapping is only going to get worse. And it's just like the horror movies where somebody menacingly says, you know, there's a storm coming. This is what everyone's life is going to be like as they start moving to containers and they have that complexity of this meshed architecture. So we decided we have to change this concept of dependencies. We have to change the concept of what's logical. A lot of people think logical is a role of a VM or something. No. For us, we've changed this to this model. We created something called performance graph. By leveraging our big data warehouse of billions of transactions, we're able to identify what are the slowest transactions, which are going to be your symptoms, and mapping those to the root causes. Because even if the distance between here and here hops through 100 containers, we know when this method contributed to the delay of one of these things. And our mapping now is based on the relationship of what's slow to why it's slow. And while this is aggregated by category, if I just flip this into just pure symptom and root cause, I now am able to see that if I want to understand why this is slow, these are the methods in SQL and so on I need to optimize in order to do that. And this will be tabulated for, like I said, billions of transactions. We're not cherry picking the slowest ones. It's collectively, this is absolutely what's causing the delay. And if I flip that and say, well, I want to optimize this. If I do, what will that impact? I can track this back to the consumers of those as well. So whereas dependency mapping historically was, if I move this database, what servers does it impact? Now I can say, if I modify this shared logging library that everyone in my enterprises uses, what is it going to impact? And this type of dependency mapping is what ultimately solves a lot of the most squirrely problems. This is based on graph theory. Right? So this is not just the mapping, the visualizations of Sandkey flow, but under the covers, we have a model of relationships, just like Facebook does to know who your friends are, LinkedIn doing the same thing. You never see these maps in LinkedIn and Facebook, but it's the underlying structure that helps us figure out that, you're friends with them and they like certain movies, so you probably will too. I'm going to send you an ad. Well, we've done that with the relationship of all of the, of the performance information under the covers. And it basically, in one click, will give you, when we're investigating a problem, and again, this is that same customer with that crazy rat's nest map, we see this massive spike in performance over a 5-minute period of time. And here we see it's this recovery service. It points to that method. And if I compare it to an hour ago, I could see that that piece was over here. It was a totally different reason for it being slow. And in one view, I've got this comprehensive analysis of billions of different things, cross-mesh transactions, and I can make sense out of the noise that comes out of cloud and microservices architectures. So I want to talk about a case study where this became practically useful. It was one of the inspirations for some of the things that we've evolved into. So I got called by a financial services company, a big bank in the US that has credit cards and loans and so on. So they have about 30 tier 1 applications, thousands of different types of transactions across all of those. And they called me on a Friday afternoon because this account details page was slow. And I asked them, I said, that wouldn't happen to be related to the fact I can't pay my credit card. And they go, it might. So I said, OK. They said, when can you roll the agents out in production? Because we were only in QA so far. And I'm like, oh, we got a plan. He's like, well, what are you doing in an hour? It was that bad. So we rolled out the agents on a couple servers. And we got some insight you'll see in a moment. But before I got there, for months, they have been trying to figure this out. They've been analyzing the slowest transactions, the top 10 slowest things. Why were they slow? Optimizing code. And nothing ever helped. And the challenge, I said, well, put the agents, but we're going to do a different methodology. Instead of saying, why are the slowest things slow, we're going to say, let's mine the big data, look at everything, not just this transaction, and figure out what are the overall slowest contributors to delay across billions and billions of things. And when we did that, I identified not some piece of code that takes a second or 2 seconds. I identified a 53 millisecond piece of code. And I'd actually found this in QA, and they told me, no, that's not in prod, don't worry about that. Well, this time I found it again, and I said, I promise you, and I gave them the evidence, if you optimize this, you're going to save hundreds of hours of processing time per day. And that got their attention. So day one, I pointed this out. Day two, they fixed it. Day three, they tested it in QA. Day four, they rolled it out to prod. Response time went from 1.1 seconds to 62 milliseconds.
Do you have a similar example with a cloud native app, something that's using containers, container hosts, et cetera, spread across a little bit more cloud native?
I mean, they were using containers here. This was a complex banking application. Okay. Imagine the biggest bank, and like this is not just like one, .NET server.
So what in the container world, whether the agent exists, it was the agents running in containers. How do you guys update the container repository?
We can run the agents in the container. We typically sidecar them, and we run them on the container host. We can run them even on the host that's running Docker. So we have different deployment models based on what makes sense.
So how does that work in a cloud model where you don't necessarily have the option to run a sidecar?
Then when you would deploy it with the code, right?
So it'd sit inside the container itself.
Yes. Yeah. So like I said, there's different ways depending on, and listen, the world's always throwing us curveballs, and we keep figuring out how to knock them out, right? So am I going to cover every one of the examples you give me today?
Well,
no, but
I guess the reason why I'm asking about this is, I mean, when you're talking about traditional infrastructure, you have a lot of flexibility, you have a lot of options. When you start moving to a cloud-based model, I mean, it's almost like you have to forget all of the ways we used to do things and say, okay, if we were to do it all over again, would we do it the same way? Or would we take a completely new and different approach to it? And I kind of wonder if there isn't a different way to handle this as opposed to how you are choosing to handle it.
I'm echoing Tim's thoughts. As I have to convince a new set of teams, whether they're DevOps teams or developers directly, hey, you know what? Riverbed has served us well in this previous era. Here's what they have to offer as we develop new applications natively. Make the transition, it is worth it, versus the competition. I'm not hearing a clear story on the value prop of Riverbed extended all the way into these new world apps to continue that value prop going forward.
I don't think that the value proposition changes. It's just there may be a lag of support for particular technology before we get there. But we have customers who used to use us on physical servers, then they started using us on VMs, and we started helping them figure out contention issues that they weren't aware of. A customer's telling me, it's like, yo, I've got 4 cores, and I'm like, yeah, but you only have 500 megahertz under the covers.
Yeah, but I don't think. Yeah,
and we went to containers. It was the same type of thing. So as everything evolves, it's still the same.
Yeah, but John, I'm gonna push back on that because I think that VMs is a bad example of that evolution, because when you're talking about VMs, the enterprise still has control of the hardware. They still have control of the data center in a lot of cases. Even if they move to colo, they lose some control there, but you still have control of the hardware, right? Unless you're doing hosted VMs on like a hosted private cloud from a colo provider, that type of model. But you still have insights into the parameters within that stack. When you move to cloud, that changes demonstrably. I mean, it forces you out of managing infrastructure, managing the underlying infrastructure, right? So that's why I'm saying I think there must be a different way to do this, because this seems like a heavy-handed approach to solving this problem using a traditional approach, solving the problem with a new methodology, the new methodology being
that may be the case. I mean, right now it's, unless there are new APIs given to us to access this data from the vendors themselves, then we have to get it through other means. And when people start developing their sites on Azure PaaS, we built NuGet modules so that they could deploy the agents right with their code right into these PaaS servers. So we're always trying to stay one step ahead. Like I said, we're not going to have the same support for every single technology, but we have customers who are making that evolution, and they're coming to us saying, you've detected a delay in the end user experience. We can't figure out why. Help us figure out why. And
are these existing customers that are just coming along as they go through their evolution, or what percentage of these are net new customers that have this problem leveraging a cloud-based infrastructure and go, you know what, you're the best solution for that?
I mean, I don't have those statistics, but
okay.
I encounter both frequently. I don't feel like the profile is more one versus another. We're doing both. Okay.
Just before we move on from that, I just wanted to ask a question. With this one, because that wasn't the slowest method, were they just calling that billions of times a second?
Aha.
Often?
See? So
yeah.
Let's answer that question. Okay. So the challenge was of how is this even possible? Because a lot of people, when I first tell the story, they're like, that doesn't make sense. It doesn't add up mathematically. Let me explain. We'll explain how we got there in a second. But before we get there, the question was, the developers said they knew this could be improved. They didn't realize how bad it was. And management said, well, how long has it been like this? And the answer's been forever. They had built this into their design from day one. It'd been years and years. And the most important question of what else uses this code? And the answer was everything. And this, again, leans back on why in microservices things get worse like this. What does everything mean to these guys? All of those 30-plus applications, 1,000 different types of transactions, all shared this common logging. And they were all incurring little delays that, in some cases, got much more prominent. This was a mutex lock, or 3 different mutex locks, that was causing contention. And then at some point, it became noticeable to the point where it set off a red light. But this had been happening everywhere. This one fix set off a cascading improvement throughout all these other transactions, all these other applications, tens of millions, hundreds of millions of transactions per day. And the way that this is possible, and again, this comes back to our approach, this is the explanation of this. If we think of this as this account details transaction, and we're just going to say that there's 2 reasons for delay here, A and Z, you're going to try to optimize A. But now if I look at some other transaction, well, maybe there's a different reason. So you're going to try to optimize B. Now that app as a whole, if there's only these 2 functions, you've got to sort of split the difference and figure out what do you focus on. As apps have more complexity under the covers and more variety, then all of a sudden what becomes significant here becomes less significant here. And as we really think about the world where we're talking about all these different microservices and meshes and these crazy interdependencies, all of a sudden what starts mattering down here? Much less. And then we take one more step back and we look at how this rolls up to the enterprise. All of a sudden now we see that what matters here hardly matters at all here. It's these common threads. Now, this is obviously a simplistic example, so Z stands out. But in that example of the 53 millisecond method, it was logging code that existed on all their microservices, on all of their tiers, and a cumulative problem. And that's where all the delay was coming from. But every tier that they opened independently and said, what are the top 10 reasons for slowness? It was never at the top 10. But unless you added up billions and billions of calls, you started realizing that those other billion things had 1,000 different reasons for slowness as the number 1 through 10. But the number 11th, across all of them, was this little guy. Why this matters is that down here is the old APM way of doing things. Why is the slow thing slow? Let's optimize it and fix something down here. If we want to do the future of let's determine what's impacting the business as a whole, target a change that has a demonstrable impact across the entire enterprise, this is something that changes the bottom line of the business. This actually will, this is about reacting to things that degrade revenue. This is about things that improve revenue, about saying, if we're an insurance company and we make more profit on auto insurance quotes, who are superstar insurance agents, independent agents who close the most auto quotes, add up everything that they do in a day and optimize their primary delays. Not make auto quotes faster, but say what is something that I can give them back 5 or 10 minutes a day. They close more quotes, more money in their pocket, more money in the company's pockets, more revenue. And this is really important. And this ties back to, we talked about the Phoenix project, which is one of the DevOps Bibles. This is one of the other ones. The goal wasn't meant to be a DevOps book, but has become adopted. The way to improve performance of an organization is by focusing on local improvements that have global impact. Traditional APM of fixing why the slowest thing is slow is a local improvement that has local impact. It fixes a very small amount. When you take the big data analysis I've been talking about, and again, with the microservices world becomes much more important, you're finding the thing that has overarching benefit. And this is what we bring to the table.
How do you feel adoption has gone with the sort of the crossing the traditional silos? Because when you talk about your solution, the challenge becomes you're basically going all the way from developers all the way basically into the back end. And I know as a sort of a DevOps person myself, I think those that are from a traditional dev background, they definitely don't think of Riverbed traditionally when they talk about APM. So how's that sort of adoption gone?
It's improving. You know, we're known as a networking company. That's why we're doing this type of event, because we're not just, right? And our networking solutions are there to improve performance, right? So it's you know, there are tools that are very flashy and do good monitoring, but they don't necessarily solve the types of problems we do. So you know, the adoption is going on. I would like it to happen faster, but it's you know, that's why we're doing events like this. But I will say that, you know, from a applicability in the enterprise, people across the board are finding benefits with this. All right, so I want to throw a couple examples of why data quality matters, about why not all data is created the same. So one of the things is your sample rate. Now this could be for a number of transactions. We'll just use time series data. We capture our data at 1 second granularity. Now why that's important is that we're in a world right now where response times, you know, we're trying to get them sub-second. So when we see a blip of response time, you know, briefly, if my infrastructure metrics, here in the real world example, I've got 5 little 1 second spikes in a 15-minute window, we're going to catch all of them. But if we sampled at 15 seconds, which is what I call the best of the rest, a lot of tools do 60, statistically, 71% chance they're not going to catch any of these, 7% chance they'll catch one. Anyone want to guess what the odds are that they'll capture all 5 of these? It's close to 1 in a million. They're effectively blind to this. It's like throwing 5 15-sided dice and hoping that they all hit 15. And why this is important is because if we now dig deeper into like digital signal processing, there's a concept of aliasing that happens where you don't sample at the right rate for a given frequency. And in the real world, we see scenarios where at the beginning of every minute, there's some task that runs, and it takes, say, 15 seconds. Now here I'm sampling every 60, and I'm not catching it at all. And if I nudge the spikes just slightly towards the sampling rate, all of a sudden, for the same data set, we get a different answer from the tool of what the value is. And if I nudge it more and more and more and more, all of a sudden I get these very, very different values. So what happens is this is rampant in monitoring where 15-second data, 60-second data is missing these types of issues. And again, 75% of the time it's reporting these like sort of zero-based values. And I see all the time where customers are saying, we're having a problem, let's look at our CPU chart from the cloud. Oh, CPU's low, can't be that, move on. Well, it was CPU, but you didn't see it because of a problem like this. And a second issue where if we don't have a synchronization of the sampling period and the spikes, imagine where we run a batch, there's a defined sleep, and then we run it again. If this gets a little bit wider, the spikes start spacing. So this is a 60-second spike. If I move it to 61, look what the resulting curve is. Right? All of a sudden, that's what it's reporting as the value of this data set. And if I move it to 62, it's different. So which one's right? Well, the blue one's right. None of the reds are right. And this is a rampant, rampant problem that I keep running into, that the wrong quality of data is misleading people. And a lot of the times when I'm helping to solve problems that have been, you know, going for weeks and months, it's because of this. So what is this? Is this some new space age helicopter that doesn't need
right? Off with a frame rate that matches the
Exactly. This is the wagon wheel effect because the frame rate matches the rotational speed of the helicopter. But if you did not know that, what would you interpret this as? What would you write as your interpretation? You'd be wrong. And we see this all the time, is that people are making decisions about what they should be fixing and optimizing based on inaccurate data. One more quick example. I'm a little bit over right now. I'm sorry. So if we're trying to have sub-second response times now, let's talk about how do we measure that. So what do you see? Lightning. That was 300 milliseconds, captured at 30 frames a second. But if I improve my granularity, now I can actually see that there's an initial cloud-to-ground strike. There are multiple simultaneous ground-to-cloud returns. There's reflashes on the plasma channels. And this is still going on. I'm still talking about it. So for the same sub-second period of time, I'm able to have a much more educated conversation about the behaviors that are happening here. In the world we live in, where we're talking about so many little things happening within the constraints of a sub-second transaction, this is where our big data matters. This is 1 minute period of time. We're not giving you 2 data points or 5 data points. We're giving you 10,000 unique samples from the individual transactions we captured, not plotted as a line chart, but as a scatter chart and faceted based on, in this case, transaction type, where we could say, well, what happened here? Why are A and B slow at the same time? I'd ask, why are they slow and fast at the same time? So I'm already gleaning information about this data set that I would not have gotten if this was a very coarse line chart. And if I flip this and say, well, let's not color it by transaction, let's color it by, say, server or technology, we'll do server. Then all of a sudden, this is orange, that's purple. We get to see that the dip is the opposite. And in fact, there's a subtlety of an oscillation between the samples. This is a load balancing issue, right? So this thing recycled, response time went up. This one, for some reason, stopped giving it as much traffic. That one went up. In an APM tool, I guarantee you methods got slower. There were code delays, but the code delays were a side effect of this infrastructural reason. And with the big data, we reveal this. We're not sending you on a goose chase to solve a symptom. We're identifying what the root cause of the problem. And this is not an isolated thing. I align this with the matrix where he asked, you always look at the code. He says, I don't see the code. I just see blonde, brunette, redhead. And what that means in our world are these patterns that just reveal themselves. We can see that there are these bands that are happening at 15 seconds, 30 seconds, and so on. We can see spikes when there's a clustering of data and then a response. We have server-side queuing, client-side queuing. And then we've got compound issues, like what the heck is going on here? Like, why is this OK and not OK at the same time? When you see these non-stochastic distributions, and a well-performing application should not have any discernible patterns. When you see this, these are your bottlenecks. These are your limitations that are causing performance issues. So in closing, if you don't have this quality of data, if you've never seen views like these, right? If you're not able to zoom in to the fractions of a second that your transactions are running on, you probably have not accurately detected issues, or you're not accurately identifying the root cause, right? So with that, again, follow me. More videos for that. And that is a real graph. We generated some load that made my face and showed it in big data. But as a line chart, I just look like a little blip. I don't look like me, which might be better for some people. So anyway, I'm well over. I'm sorry.
Yes. To get that granularity of data, does that mean I need to do more polling to pull in that data to the big data engine?
No, our instrumentation handles it. We have auto tuning that will find all the code, find all the transactions. It will add 250 nanoseconds to the methods it touches. It auto filters out the things that cause hotspots. You don't have to pick packages or anything like that. It's really, really smart stuff. You can afford to do this in large scales, high volume in production.